Okay, all right, so I'm starting over. So by now, you guys have done enough research on the climate of Claremont Foothill Community Area to know when there are periods when you're going to require heating, and then you also should know when there are periods when you're going to be requiring cooling. You should know about the solar geometry for the area. You should understand it completely. If you don't, then I hate to say it, but you're failing this class. If you do not have a clear picture of, by now, at the end of the 6th week of the semester, of when in Claremont you might need heating and when you might need cooling, you're not getting anything out of this class. So it's really important, and it may just be that some of you are not necessarily putting in the time that's required to learn what needs to be learned in the class. I don't know. Okay. I know that when I look through some of the homework assignments, I'm not seeing almost anything there, which tells me that people are not doing the homework. So the issue of when you need heating, we are going to assume that there's always going to be solar access. Okay, even though, as I mentioned a moment ago, today's cloudy, so the day wouldn't be a great day for solar heating. Okay, not that you would need it today. You understand that we're going to have a backup system, so if it's cloudy and it's cold out, that the heater will come on and it'll take care of things. Okay? So for cooling, we have a different situation occurring. For cooling, there are going to be times, right, when you can cool the house off to get it comfortable for humans, and there are going to be times when it's absolutely impossible to cool that house off. Okay? So if the average temperature stays somewhere between, let's call it 68 and about 75 degrees, the average temperature, that is every hour averaged out, then you can probably keep the place cool. You might be able to get it cool enough with ceiling fans, right? So that's another thing that you have to be able to determine. When is the average temperature in that range? So you have to look at the calendar and you have to determine, okay, well, the average temperature is obviously in that range in December, but do we need passive cooling in December? Hell no. So this is what makes this type of design so much more complex than other things, is that there are all of these variables coming together. So you have to look at it from the perspective of, when do I need cooling? And you look at it and say, all right, if it's within a certain range, I can cross-ventilate the house and it's comfortable. But when it gets above a certain range, there's no way. There's no way that you're going to cool that house off. So chances are that in August, which is what we would refer to as peak thermal heat or thermal summer, right? It's actually closer to fall, but it's thermal summer because it's the peak of summer because of thermal lag. Yeah, chances are you're not going to be able to keep that house cool just with passive means, and so at that point, you are going to, have to rely on air conditioning or other means. You can reduce it, okay? So I asked you guys to go through your strategies and sort of pick strategies, both from the book as well as from your climate consultant stuff. Okay, so the assumption I am working on is that everybody is using some form of passive solar, right? So all of you are using some sort of passive solar. I think I asked that question already, and everybody said yes. So the question becomes is, which passive solar are you using? Direct, indirect, or isolated? Okay, so that's a question you have to answer. Okay. So when it comes to passive cooling, right, there's a different set of questions that got to be asked there. So what passive cooling techniques are people using? So the assumptions I'm making is that you guys are going to use cross ventilation, but maybe you're not. Okay, maybe cross ventilation isn't something that you're going to use. I'm not sure. Cross ventilation is probably the most basic and simple form. right? Another one is going to be thermal mass. And thermal mass actually falls into both categories. And the thermal mass, more than likely, will have to be used with night flushing. Okay? So those things are going to have a complete and direct impact on your design. Okay? So cross ventilation. Can you build a nice square box with like rooms like you might have in your current house? Is that going to cross ventilate real well? Maybe it could if you had certain outlets and inlets for things, but chances are that it's not going to work too well. Passive heating. Is it going to work well to have a long, narrow volume with the short side facing to the south? No, it's not going to work. So those things are having direct impacts on your design. And so what we need to do is we need to take your designs and kind of put them up on the board and then just start basically doing critiques. So we're going to have pinups where you guys show us your current design. And we're going to analyze it from a passive solar perspective, right? And we're going to analyze it from simple cross ventilation and night flushing of thermal mass. Okay? Two simple, low-lying sort of factors. Any questions about that? Okay. One of the things that I asked you guys to do for passive solar is to come up with a list of rooms, right? The size of the room and the size of the solar collector. Let's call it on December 22nd at solar noon. Okay? But when I looked on the submissions, I didn't get a whole lot of that. So I don't know if you guys did that or not. And I don't know how you can design the project without knowing that. Okay? So should we just pin up now, or how should we handle this? Yes? Okay. All right, so let's go ahead and stop the